Welcome to the Team 4 DornerWorks seL4 Doom Pendulum demo short video. Here is Team 4. From left to right we have our faculty advisor Dr. Krug, Joel Myers, Alex Kaiser, Eric Speidel, Mitchell Sherwood, Alex Konworski, and Owen Gibson. What is our project? So our project is meant to show off the usefulness of a hypervisor, which is a piece of software that allows multiple operating systems to run on a single piece of hardware. In this case, we have an operating system running Chocolate Doom and another operating system running an inverted pendulum algorithm. Again, all on the same piece of hardware. And then there's a big red button in the demo that can be pressed, and when you press that button, it shuts down the Doom game, but it keeps the pendulum going. So it shows that even though they're on the same piece of hardware, they're still running completely separately. seL4 is the hypervisor that we're using in this project, and it's the hypervisor that DornerWorks uses in a lot of their projects as well. It was developed in Sydney, Australia. It's formally verified, so it has a lot of security, and a lot of the customers that DornerWorks sells to are defense, and so it provides high assurance and high performance, which is very key in those scenarios. They need fast and secure software solutions. The DornerWorks Secure Tech team specifically is who this demo is for, and they specialize in hypervisors, virtualization, and kernel drivers. The demo is needed to show off the benefits of virtualization because it's pretty hard to show why you would want virtualization without some sort of visual demo. So that's why this demo was created. DornerWorks started this demo, and as you can see on the right, this is their version of the demo that's running. You notice that it has the two operating systems here that are labeled as VMs. And then down here is where all the hardware that is used. So here's the big red button, here's the pendulum, and then a big thing to note is that this Arduino right here was used to actually control the motors and encoders on the pendulum. And then that data was fed back into the single piece of hardware through a UART port. There were some problems with DornerWorks' version of the demo. Specifically, that Arduino that I just mentioned adds a lot of confusion. A lot of people come out to the demo and think that the first piece of hardware is running Doom, and then the Arduino is actually controlling the pendulum, which isn't true. It's just kind of a liaison between the pendulum and the first piece of hardware. As well as there's a shield that sits on top of the hardware, the Ultra 96, that allows all these connections to be made, but that had some issues in it. The hardware that was used for the pendulum was cheaper, so they're cheaper motors and encoders. And then the inverted pendulum algorithm that was being used was written in Python, which is slower because the language is interpreted rather than a compiled language like C. And then it was also using a full Linux operating system just for the inverted pendulum, which is really overkill because it's running just one process, so we don't need all of that overhead. So the improvements that Team 4 made, first, the big one was removing the Arduino microcontroller so that it was able to run without that, and it got rid of a lot of the confusion that would come with people walking up to it and saying, why is this here? Like, why do you need an Arduino? So that's gone now, which is great. The PCB that sits on top of the hardware has all of its issues fixed, and actually a couple improvements made too. The encoders that we use for the pendulum are a lot better. They're higher resolution. And then we improved the algorithm as well. So it runs a much smaller, lighter weight operating system, and it's also been rewritten into C, which is compiled, so it's much faster than Python. Here is the final build for Team 4, so a lot cleaner, as you can see. You just have the board, it plugs right in, and then the monitor behind there and the button plugs in the same. So it's a lot cleaner and easier to set up as well. And then here is Team 4's version of the demo running. As you can see, there's no Arduino, nothing like that. The game's running fine, and then you can even poke the pendulum a little bit and it will recover. So thanks so much for watching. If you'd like a more detailed version, please see our 10-minute video.